All right, in this video, we're going to go over two very typical integration problems. First, we're going to learn how to find the area between two x values and the x-axis and a curve that's going to eventually involve the natural log. And then we're going to solve a differential equation. So stuff we've done before, but all involving the natural log. Let's dive. So we're told to find the area of the region bounded by that. I've given you that curve. So 8x over x squared plus 1 is this curve. Pretty gnarly looking. That's evaluated from y equals 0, right? Bounded by that, I should say. Y equals 0. And then from x equals 0 to x equals 3. No problem. So essentially, we need to set up our integral. That's going to be the antiderivative, or the integral of, I'm going to factor out the 8, right? From this, x over x squared plus 1 dx. And that's evaluated from 0 to 3. So that's all that is involved there. It's the definite integral, right? So, okay, how do we do this? Well, the same as we've always done. We're going to do some u substitution because I noticed the derivative of x squared plus 1 is going to involve x. So I've got u equals x squared plus 1. Nice. Du is equal to 2x dx. All right, well, we got to put in that 2 there. So I've got a 2x dx now, but I've got to divide by 2. And now we're ready to substitute. So I got 4 times the definite integral. 2x dx is du. Nice. All over x squared plus 1 is u. That's pretty awesome. Now we have bounds that we need to substitute in for. So when x is equal to 0, we get 0 squared, right? You've got u equals 0 squared plus 1, which is equal to 1. It's my lower bound. And when x was equal to 3, we've got u equals, 3 squared plus 1. That's going to be 10. Whatever, we'll deal. That's equal to 10. Nice. So now we're just going to integrate it as normal. So I've got the 4 hanging out. The integral of 1 over u, well, the derivative of what gives me u? 1 over u. That would be ln of the absolute value of u, evaluated from 1 to 10. That's it. It's the same as we've always done, just with the ln. Plug in 10. You've got 4 ln of 10. Minus 4 ln of 1. Now I skipped the absolute value because the absolute value of a positive 10 is 10, and the absolute value of a positive 1 is 1. So that's your final answer, except we could simplify a little more. Ln of 1, e to the what gives you 1, that goes to 0. So you get 4 ln of 10. Some people might even raise the 4 up here and get 4 ln 10 is ln 10 to the 4th, or ln of 10,000. We'll just leave it here. That's the area, right there. All right. Next problem. Solve the differential equation with the given initial condition. Don't mind if we do. So, how do we deal with a problem like this? Well, if I'm solving the differential equation, that is specifically asking you for what y equals. So we need to solve for c. Let's do that. So I'm going to start out by integrating. This is an interesting integral. So we'll integrate both sides with respect to x. So that 5, let's just take that out. So that's going to be 1 over x ln x dx. I'm integrating because I'm given the derivative and I want the antiderivative. And now to integrate that, ooh, that's a tough one. I like it. Well, notice that the derivative of ln of x is 1 over x. U substitution. So we're going to let u equal to ln of x. Its derivative, du, is 1 over x dx. That is right here, 1 over x dx, no substitution needed. So I've got 5 integral, 1 over x dx is du, all over ln of x is u. So now we're also left with 1 over u, and the derivative of what is 1 over u? Well, you get the 5, ln of the absolute value of u plus c. Well, let's plug it back in, plug it being u. So u is ln of x. Nice, we need the absolute value, I guess, because ln can technically equal out negative numbers. That's gross. Grosser, we got to plug in e, right? So when we plug in e, that's your y value. We get out 4. So we get 5 times ln of e. I'll write all this out, plus c. So you get 4 equals 5 ln. Ln of e is 1, because e to the what gives you e? 1. So all of that goes to 1, plus c. The ln of 1, that's 0, because e to the 0 is 1. Ooh, well this is working out very nicely. C is equal to 4. So we take our original answer here, and we plug in. So y is equal to 5 ln of x. Absolute value still standing, plus 4. Oh, Gross looking, but it was all about noticing that U substitution is involved there. And then we're in great shape. Awesome stuff. I'll see you in one more video in this lesson where we talk about secant x and cosecant x. Ugh. It'll be fun though, I promise. It won't be whatever that sound and face was that I just made. Peace.